Hello again, Noah Housley with problem set 1 from Chem 105 this time. Okay, once again, these are just to help me to study just the things that I learn and maybe the things that I see are important or maybe going to be tested on. But I'm making sure I'm pulling from right sources that these are correct. So hopefully you can pull from these what I do. First, from problem set 1, we talked about the definition of chemistry. And just a base to get in your head is chemistry is the study of matter. I like to think of it as that biology is the study of living stuff, chemistry is the study of living stuff, or no, is of stuff in general. So biology is the study of living stuff, chemistry is the study of stuff, and then physics can be the study of how stuff moves or why it does what it does. I don't know, that just fixes in my head. I'm more of a physics guy myself. Okay, moving on. We have compound versus element versus a mixture of what we talked about. Some examples is salt water, we learned is a homogeneous mixture because homogeneous meaning that it's uniform within the substance. That's the main difference that you want to think about when it comes to homogeneous or heterogeneous is that is it uniform in the substance? Something that's not uniform in the substance would be a high pulp orange juice. You know how you have to shake the orange juice before you pour it in, especially if it has pulp in it. It's because all the pulp is at the bottom, and you don't want super watery top and then super thick bottom. You want to shake it up and get it kind of even. So that would be an example of heterogeneous because it's not uniform. Surprising one was compressed air. So compressed air in like a scuba tank. We all thought it was an element, but it turned out to be heterogeneous, at least my group. It turned out to be a heterogeneous mixture. And we learned it was because it is uniform within the tank and it's distributed evenly, but there are different elements and compounds in there, like nitrogen and oxygen, and maybe even some H2O or whatever. There's always H2O in the air. Solid butter was another one. A lot of people thought that was a compound, but it turns out it's an homogeneous mixture. For one, it is uniform. You don't have chunks of fat in your butter. That'd be disgusting. And it is a mixture. There are different materials in there. There's fat and dairy and things like that. At least as far as I know, I've never made butter. All right, next thing we had is chemical versus physical change. So what I want to talk about is fish rotting. So a lot of people thought that just fish sitting there starting to smell bad was just a physical change. But the evidence of a different smell, of the smell getting worse, is evidence of a new gas being released. That's definitely evidence of a chemical change. So that's what you want to think about. When you're looking for chemical changes, you want to look for, changes in color, gas, if there's new gas being released, temperature, I don't know if there's a fourth one, but those are usually the ones I look for, like if there's a color change, gas color, or energy being given off, energy given off. Like if it starts glowing, like a glow stick or something, that's a chemical change. Very good. Soda going flat, though, this is a confusing one for me. Turns out that CO2 is not bound, yeah, that's a better word, bound to the water and sugar molecules and compounds in the soda. And so this is just a physical change. The CO2 is just escaping. There's nothing being created anew. Your soda is not different now. Okay, now let's talk about physical property versus a chemical property. So physical properties, these are things that can be measured and observed. That's an eyeball if you can't tell. I'm really bad at drawing. Is that a little better? Oh well, that's okay. Okay, so they're measured and observed without any reactions to a different chemical. So things you want to look out for when you're being tested on these is if there's a substance that's alone. So if you have gold and the question asks you, gold does this when heated at this point. You may think like, oh, well, there's heat, so that could be a chemical change because usually heat and fire means chemical change, but you want to say nope to that because gold, for it to be a chemical property, means that it has to react with something else like silver. I don't know if those two react, but that's why I'm in this class. Physical property, so chemical property is there's two different elements. Focus on that. Okay, very good. All right. Briefly, we're almost done here. Hypothesis and theory. So these questions might not seem hard, but then they always come up in the final, and you're like, dang, I wish I studied that. So I'm putting them in this. Hypothesis is, the question was, how does hypothesis become a scientific theory? And really, hypothesis to become a scientific theory is you just need to test it. And then, well, I guess that was this one. And then why are they different? What makes them different is that this is more of from observation. If you remember the scientific method that was shown in class, it goes observation and then it goes to hypothesis because you're making a prediction. Versus a theory is created after already testing the hypothesis. Those are the differences. Hopefully you don't forget those on the final or something. All right. This one I wanted to spend the most time on. Energy and work. So I'm a physics guy, and I talked about work a lot. I also talked about energy. And I was very confused when these two were kind of put together and put similar. But then I realized that's for a reason. So in physics, we did this with distance, and it was an integral of force in respect to x being the displacement of an object. And this was respect to how fast an object was motion. This is kinetic energy right here. It can also be put into MGH for potential energy, one of the many equations for potential energy. So I was confused because this comes out in joules and this comes out in joules. And I was like, wait a second, but aren't they different? They both come out in joules. Teacher explains that kinetic energy, that while work and energy have the same units, they represent different things. So the difference between work and energy is that work is over a distance / displacement if you're a physics nerd. Whereas energy is just the capacity to do work. So it's probably easiest to think about energy as like the battery, especially potential energy is just the battery. It's this capacity to do work. Or in kinetic energy is the energy of motion. So kinetic energy definitely has the capacity to move something. And work is just something moved, how many joules did it take to move, or how many joules will it take to move this object. Things like that. All right. And finally, potential energy. I thought this is an interesting definition because I always thought of it as a stored energy, that energy is being stored inside an object. But a better definition from the professor is potential energy is due to position in a field. Examples of field is a gravity field, a chemical field of atoms and compounds being bonded together, or an electric field. So I thought that was a good definition for potential energy. All right, that was problem set number 1. See you soon.